Okay, in regular chemistry, we're going to start talking about chemical bonding. You might want to make sure you have a periodic table, and specifically the one that has the EN values on the back that was sent to you. Okay, so why do chemical bonds form? Well, atoms will either transfer electrons to form ionic compounds, or they will share electrons to form covalent or molecular compounds. So we drew your ionic compounds, or no, excuse me, we talked about naming and formula writing for ionic and molecular compounds in the last chapter. So this chapter we're going to talk about why this happens. In both cases, the bond forms because of an increase in stability, which means these compounds will be of lower potential energy. By forming bonds, atoms will acquire an octet of electrons, that means 8 electrons in their outer shell, and the stable electron configuration of a noble gas. Atoms are often more stable when they are bonded in compounds than when they are free atoms. Okay, so there are one way that we can tell what or determine what kind of bond is going to be formed is we can look at the difference in their EN value. So that is the Greek letter delta. It can stand for several different things in chemistry, but in this instance it means difference in. So you can use the difference in electronegativities between two atoms to predict bond types. If it is an ionic bond that's going to be formed, electrons, remember, are transferred, creating cations and anions. So remember that if a metal gives up an electron, 1 or 2 or 3 electrons, it has a positive charge and it's called a cation, and nonmetals will take those electrons and become negatively charged, and they're called your anions. Usually, we're going to say it's an ionic bond when the difference in EN values is greater than 1.7. Now, different books might use like 1.6 or 1.8. Okay, we're going to go with 1.7. Covalent bonds are where electrons are shared. Sometimes they are called molecular bonds. Now, there are 2 types of covalent bonds. One type is called polar covalent bonds, and this is when 2 atoms form a covalent bond, but one atom attracts the electrons more strongly than the other. So it has a higher EN value, so it pulls the electrons more to itself. So the electrons are not shared equally. And we're going to consider it to be polar covalent when the difference in EN values lies anywhere from 0.3 to 1.7. Obviously, as it gets to 1.7, it's almost ionic. As it gets to closer to 1.3, it's going to almost be nonpolar covalent. Nonpolar covalent is where the electrons are shared, but they're shared equally. So they spend equal time in both atoms' orbit. This occurs in the 7 diatomic elements. So on your table, if I'm not mistaken, we marked your 7 diatomic elements. They start with the element 7 and they make a 7. NOFClBri, but that is only 6, so we're going to add hydrogen. So that just simply means that when they're alone, they bond back to themselves. So it's like N2, O2, F2, Cl2, Br2, I2. They will always be nonpolar because they have the same EN value. So if you subtract one EN value from the exact same thing, it's going to be 0. And then you can have other elements, also diatomic elements, that can be nonpolar also. And we're going to consider them to be nonpolar if their difference in EN is below 0.3. Okay, so you're going to predict whether the following pairs of atoms will form ionic bonds, polar covalent bonds, or nonpolar covalent bonds based on ENs, difference in ENs. So what I would do is I would go get my electronegativity table out. I would write above each element, I would write their EN value. So for instance, boron is 2.0, phosphorus is 2.1. So when you take the difference between those two, that is 0.1. And so since it's 0.1, that is less than 0.3. So this would be a nonpolar covalent. So put the video on pause for a second and try to determine what each of these are. It's easiest if you'll just look them all up at one time, write them above it, do your math, and then decide. Okay, hopefully for carbon you said 2.5. Phosphorus was 0.9. That difference is 1.6. So that is going to be considered polar covalent. It is almost ionic. So that electron is almost completely pulled off of sodium and goes to carbon, but it's not quite. So this is polar covalent. So they're sharing but very unequally. Okay, beryllium was 1.5. Silicon was 1.8. That is a difference of 0.3. And so, once again, that is polar covalent. It is almost nonpolar. Okay, so they're almost shared equally, but not quite. Your silicon will have them in its orbital a little bit more. And then the last one, lithium, was 1.0, and then oxygen is 3.5. That difference is 2.5, so this is a definite ionic bond. Okay? All right, that finishes it for this section, so now you can do your homework set 1. Thank you.